Okay, let's see if we're on. All right, how's everyone doing? So today I had an idea because a buddy of mine was talking about using AI to find a job recently, and I was like, let me do that my way. Let me try to figure out a really, well, what I mean by my way is a really hacky solution for that. So we'll see. I so my thoughts are if I wanted to use AI to find a job, I'm going to have to utilize some pattern recognition in order to find the best jobs. So, my thought was what if we made a script where you could find a job, you know the perfect job description, and because finding a job and like is typically or finding the job descriptions to apply to for new software engineers and all that is typically hard because people just don't know where to look for for job descriptions and how to apply and resumes and things like that. So I'm thinking, what if we made a script today where you find just one, so everyone could typically find one thing that works. So you find one job description that works, and we make a script where it automatically finds the highest similar job descriptions across the web. Um, so my main thoughts are we're going to want to use, let me get into the code. We're going to want to use some, don't mind this. This is just proprietary code. Okay, but we're going to want to use some word embeddings. So we're not going to do anything too crazy, but we're going to use Word2Vec, Python implementation of Word2Vec, and we're going to obviously make a crawler using Puppeteer as we always do. And also, so we're going to mix some JavaScript, some Python, and some k-means clustering in order to sort of, well, actually, we don't even need to do k-means clustering. Let me think. We can probably actually get away with doing just some cosine similarity in order to find high matching ones. We'll see. We'll see. But the first thing I want to do is I do want to get embeddings for the job descriptions. So let's do this. So the first thing we need to do is make a directory. Let me make this bigger for you. So the first thing I like to do whenever I code anything is I like to make a directory. All right. So first thing, what are we going to call this? So let's call this job finder lead. So cheesy. But all right, let's create this. Let's open this up. Why did I call it job finder lead when I could call it lead job finder? Am I fucking stupid? All right, so let's call this lead job finder. That matters. What you name things matters because it sticks with it for a long, long, long time. All right, let's open this up. I use Sublime Text for everything. I don't know. I use it for so long that it just feels right. All right, so let's create. So this is going to be like a quasi Python. If you don't know already, I code mostly in just like Python, JavaScript. That's just, I think you can get by with, in the high level, get by with most things you want to do with Python and JavaScript, Node.js. Python's just so good it's just so versatile. And I've been using both those things for like 10 years. So it's got some comfortability with it. So first things first here, I think we want to start making the crawler, and we're going to get into the word embeddings later. So I actually, let's not do that. Let's actually do because we've been doing a lot of crawlers recently. Let's do the word embeddings first. And I'm going to steal some code I have for some Word2Vec. So let's make the way I want this to work is I want to pass in a job description to this command line tool. Let's say let's actually make a README for our project. And in this README, let's call this is the Leet job finder. And what this does is, I'm just so like autistic about names. But like, so what this is we're gonna make something where it's gonna be a command line tool. So let's just call it Leet JF. And the way we're gonna use it, if you don't know, these 3 backticks right here are for creating like a code block to get rendered in GitHub. So in the Markdown, GitHub's Markdown. So what we want to do here is we want to say pass in a URL for a job description, any job description. So we'll figure out how to like make a generic crawler for this. I'm thinking this command line tool can actually be a node script, and then for all the word embeddings and everything, we can use what am I saying? We can spawn Python processes for that. So what we're gonna do is what to do. So what we're gonna do is, first things first, we need to create a, hold on a sec. We need to create a crawler to crawl through tons and tons of jobs and scrape the content generically. Then we need to write a script to scrape, well, yeah, let's write this. Scrape the imputed job passed by URL. Then we need to create embeddings for, and also if you want to, yeah, we can use OpenAI embeddings that actually probably work really well. Right now, I want to show you guys how to use Word2Vec, Doc2Vec, and just because I think Doc2Vec and Word2Vec are just really cool things and that are just building blocks for a lot of what's happening in machine learning right now. So, and what I use is GenSim for Doc2Vec and everything. And I actually don't have a ton of experience with Word and with GenSim, but in fact, so far my experience with it is not like super thrilling. I actually didn't like. It needs a lot of work, especially with like logging and things like that. Like Word2Vec is good, but Doc2Vec, their implementation is not that great. But it's kind of the only thing I use so far, so we're gonna use that. Which is how things go typically. It's like if I've used this before, I will use it again until I can't. Alright, so we need to create embeddings for our entire job corpus. So here's another thing. We're going to pre-train our Word2Vec model. So there's not going to be any, we're not going to be like, it's just going to be something that's, they're probably going to use Doc2Vec. And I'll get into what these things are in a little bit. So we're going to be just like training a whole Word2Vec thing first on all these job descriptions. And then we're going to generate the embeddings after the fact. But anyway, so we're going to pre-train our Word2Vec model. And what am I saying? Right. So also going to pre-crawl everything we need. So we're not going to, by the way, I love writing things out before a project like this where it's like I say what to do And when I say what to do, I'm like, this is how I speak in how I write out my to do list and everything. It's like I need to do this, I need to do this, we need to do this, we need to do this. We're not going to do this. We're going to do this. It makes it so you're speaking sort of confidently about your product before you make it. Okay, we're not going to we're not going to fetch new jobs when a prediction is made. So what I mean by that is, let's see, on inference. So what I mean by that is when someone uses this tool, we're just going to look at our database. Just going to look at what's saved in the DB. And we'll figure out how to save them in the database. I don't know if we're actually going to use like a legit database. I don't think that's actually necessary. I'm trying to think if that's necessary. We could just, for now, we just use a big JSON file, honestly. I don't want to, I mean, we don't have a lot of time, so. So, the database, for now, a big JSON file. I know, I get it. It's not great. But alright, so, but in general, I probably would want to use like MongoDB for this. This is very unstructured data we have here. Cool, so let's start writing. This is kind of everything. Oh yeah, so the actual process for finding similar jobs. So that's what this does, by the way. This finds similar jobs based on a URL passed to the script. And so in the JSON file, we're going to have it structured like the URL to the job, and maybe, you know, some other info like title. And then we're going to want to have the embedding. And you'll see what that is later. This is just going to be big matrix. All right. So, or a big vector. Okay, so the database, and so the actual process for sending. So right now, I'm thinking we just want to do cosine similarity, which is just a way to compare vectors are similar, and we're just going to rank them based on cosine similarity. So I think that should probably be enough. All right, so let's get started. I just realized I'm not even coding in the README. I need to copy this. I was like, why is it not, why is it not actually highlighted? Okay, cool. So first things first, let's set up all the Word2Vec things first, because we've been doing too many crawlers. It's just too much. So let's start with, let's just make a file for Elite.js. Actually, so this is going to be the embedding. Let's just say train model. And this is going to be our pretty simple Word2Vec model. So let's just call this like model. Grab a class. I'm actually going to copy some shit from another project I have, which should be down here. Let me see. Do I have it in here? Dang, I've been making so much stuff. Always have projects, by the way. Alright, so let me find this. Thing. As I don't care if you guys see. I mean, I have like so many projects here. Let's see. I was working on something called, it's in my experiments, and it is I can have a whole video on supercoder. Supercoder is very neat. HTML prep. Is this it? No, actually, this is not it. It's the other supercoder. So right now I'm just finding the script I originally had for all my HTML. So I have another script where I use Word2Vec a lot, and I'm just gonna like use a lot of this shit. So, in fact, I'm actually gonna just like take a ton of stuff. By the way, this is how coding is. You don't just, this is how it is. You typically just kind of move things from other stuff a lot. I don't think I'm using any of these. Actually, let's not use too many things. I don't think we're gonna use beautiful soup in here because I want to actually do the scraping in let me think. Yeah, I want to do the scraping in JavaScript. I always typically want to scrape in JavaScript, but we'll do that later. And we're going to use NLTK for the tokenizing. We don't have to do that. We don't really have to do a lot of this stuff. This is all, I can talk about this project some other time, but alright, so let's create a model here. So this is just going to be our word model. Let's just say job model, just to be, you know, it's kind of job description model. JD model, no, job description model. So what this is going to be is this is going to be something in which we train a model that, actually, let's rename this file. Job description model. This is going to be the model that we use in order to, we're going to pass in a ton of scripts to this. So actually let's our job list is going to be something that we pass to this. And by the way, if you're not familiar with Python, always write stuff in classes. Python is actually meant to be object-oriented, unlike JavaScript, and it helps so much. Especially once you start having to superclasses, you start having to have a ton of different attributes that you want to pass around. You want to have interfaces. You know, there's actually ways to write interfaces in Python. Well, not like super straightforward, but all right. So actually, we want to initialize the model in here. So let's so let me talk a little bit about Word2Vec and Doc2Vec. So I actually, is there a way for me to like, is there like a MS Paint thing? But so pretty much, let me find some Paint thing for you guys to look at. Just so you can kind of see, I can like draw stuff out. So Word2Vec. So what Word2Vec is, let me make this big. Okay, so what Word2Vec is essentially something in which you vectorize words. So let's make this smaller. Vectorizing words. And what I mean by that is you're getting some words. So let's say, hello, I am a dog. I'm a job. I'm a dog. And you're going to be, let's make this like 40. And you're going to be converting, it's very high level. It's not getting too crazy about it, but you're going to be converting this into numbers. So maybe you have -0.032, comma 33, comma 42, 43, comma 0.22 point whatever. Here's another thing here, comma 1. But so yeah, these are super random numbers. But like, so really the concept is, let's say you give something a huge amount of text. So like I give something a huge amount of text. So I have a language model. That's why did I just do that? Let me just actually keep using the text thing. But I have a huge amount of text. Text that is a large corpus of text, meaning like a lot of text. Oh my god, it's like getting off the page. Let's do that. How do I expand this? Oh, you know what? We found a shitty edit. Wow, look at that. We found like the worst editor we possibly could find. See what happens when you don't do research. Alright, well, whatever. So if you have a large corpus of text, yeah, it's like not letting me, oh, now it's letting me expand it, now that I freaked out. Okay, so either way, doesn't matter. So if you have a lot of text, let's say you have like the entire Wikipedia, every single time when you use something like Word2Vec, what it's doing is it's learning a representation. It's representation learning for each one of these words. So text that is, and all of these things based on a window. And when I say window, what I mean is this would be a window of 6 words. So if we said in a window of 6 words, learn about each individual words. Wow, this is, oh, I'm doing like sketchy. Let's say that's not good. So text, let me undo that. So like, let's say I have a window right here of 6 words. So what the model's doing is it's looking at this window and it's saying text is related in that position is related to that. That occurs in front of text and behind that is, and also not everyone works forward and backwards like that, but that's a separate issue. But really, it's saying, okay, text. If I was going to graph with the word text and make it a point on an X and Y graph, which is what all these numbers are, is like text would be like right here, that would be like right here, corpus would be like right here because it's similar to text, you know. And that's what all these numbers really are representing. It's something, it's something in a plane, and the numbers don't actually end up being like one-to-one like this. It's just kind of like a rough example. It can, but so this window, the reason why the window is a certain size is because it might change depending on what you want to learn from your model. So if it's a very large context windows, you're probably going to be less so learning about the individual words as much as you're going to be learning about essentially the overarching topics. And you're getting less depth into the understanding of each individual word. But yeah, so, and I'm not like an expert on this at all. This is like all stuff that I'm regurgitating from things that I've learned pretty recently. But this is the general concept. So, and as the model goes through the corpus, through one cycle of training, through one epoch, it's going to keep, the window's going to keep moving over one iteration, and it's okay. That occurs through this sequence with of, and then now is the first word, and now you're going to see how all these words relate. And up, you have text again. We had text in the first window, and now in this third iteration, we have text now next to of, which is a new understanding. So now the word of text is actually going to shift maybe from here up to there or something like that. So as the context window moves over and over and over, you're having a different understanding of what these words are. And then eventually you can vectorize the words. I mean, you're creating embeddings, some numerical representations of these real world things. So what we're going to be doing, going back to our code, is we're going to be creating we're actually going to be using doc2vec, which is, we're going to create a vector for the entire document instead of word2vec. We're going to be comparing documents. So we're going to be essentially vectorizing, and this uses word2vec as an underlying concept, but it sort of adds this concept about paragraphs to it. So we're going to be setting the vector size to 32. I'm hoping cosine similarity will be good enough. These will all be the same size and everything. But what I mean by cosine similarity is eventually we want to rank these embeddings, and cosine similarity is a concept for ranking, or not ranking, just seeing if two vectors are similar. It's very basic algorithm. All right, so minimum counts. This is going to filter out, I believe, any doc that has less than 10 words from the training, which is fine. Actually, we don't really need this. I'm going to do 5. I think that's what it originally was. I think we want to do more than 32. Let's do 64. The Windows 500, we don't need to do that. I was doing a separate thing where the window is really large. Let's do a window of like 20. We don't really need workers. Let's do 2 epochs for now. Let's not do loss. Okay, so this is our model. I'm going to go back, and so let's assume we have a job list, and the job list is a list of strings for each job. Large strings for each job. And let's see, define, let's just have a train method. I think we literally just want to train. And we have to add self because this is a class, and we need the instance of the class to, we need each of these methods to be attached to the instance of the class, so that we can use these values across, these attributes across methods. And once we create a new instance of this, and if we create a child class and we do things like that, that this self is going to start mattering more. We're going to be able to pass it around, and this self is going to sort of be the object that we're going to be using later on from when we create the object from the class, when we instantiate the object from the class. Okay, so, oh yeah, so I forgot. So they have this concept of building the vocab. Let's do that when we instantiate the class. So let's assuming this is a list of large strings. How did I build a vocab? Oh yeah, I actually want to do this. I just want to log this. I always like logging the vocab size when I'm doing like language model stuff, because it's super important. Constraining your vocab size is gonna, with a large corpus of data, to a point, is gonna make it so that each individual word's representation is gonna be pretty powerful. But it depends. It's not. That doesn't mean that it's a zero-sum thing, because you're losing some variability as well. So It's not like that means it's better, but for instance, we don't want to just. What I mean by that is, for instance, like right now, I'm just going to scrape software engineer related jobs because the terminology is going to be pretty uh, similar across these things. But if we start adding nursing to it, then like a lot of those words are not going to be related at all to these other words. Which is where things like TF-IDF come into play, which we don't have to get into. This is a whole other part of this where we can start topic modeling. But anyway, so let's go into, yeah, oh yeah, I was doing a whole HTML thing. This is actually a pretty cool script. I said I wasn't going to talk about it, but I made a thing to essentially make embeddings from HTML with the design, so with the styling. But anyway, so I just want to see, tagged document. Is this what we need? And then the tokens, what are the tokens? It's this right here. So the tokens is just a list of strings, and then we have a tagged document. Okay, so I don't really like that. It seems like we need to have a list of tagged documents for each job list. Okay, so let's do this. For job description. So I'm not doing this backwards. It's weird going back and forth between different languages. Like I was using Go the other day. I was like, this is like a whole different world. And it's like using. Actually, let me do Java and scroll this. I'm using JavaScript, which like doesn't make any sense in any realm. So, all right. So this looks like. Let me just make sure. Am I passing up all the functions here? Yeah, this is just a series. The training data is just a series of tag documents. Okay. I mean, that seems fine. Training data. And then tokens. It's more just job description. And then why is it index? What is index? Oh, I think I enumerate the other one. Enumeration is just, you're really just creating like a little pointer index when you're looping over things. And I think it is the first. And yeah, it's like that. Cool. And what else do I do? Yeah, okay. Alright, so yeah, when you tag these documents. So yeah, the document tagging, the paragraph like ID here is the main separator between Word to Vec and Doc to Vec. It's very similar things. First, let me just see if this. I type in pass, by the way, when I write functions because. And by the way, if you're wondering why if name equals main gets used, it's because if this is the main module, meaning this was initiated, like this is like executed with Python directly as a module. So when you type in Python file name or whatever, it's gonna this name attribute of the file is gonna be equal to main. So this is a good way of. So if I wanted to import this file and then use it, then this wouldn't get used, which I probably want to do because this is like a useful class that we can like use multiple places. All right, so if you're a smart engineer, if you're an elite level hacksaw, 10x, and you get the little wrist. I jerk off too much wristband too. If you do that, then you always remember that when you initiate your file in your if underscore name, main, and everything, you always remember that it's something that is non-repeatable. That's not something that you can simply just have another file for. 'Cause I see that a lot where people will write a ton of stuff here, and it's like you could have just had a separate, like, eventually some people, this will just be its own routine. That's like, it's like, why don't you just have another class for all this stuff? Like, it'll be a ton of logic in their main function here. And the same thing goes for if you're writing like C. It's like, really think about whether you need to have more headers, whether you need to have more classes, everything like that. We can have more larger structs or more sparse, uh, more, it's not sparse. I mean, just many structures. Really think about that, because you can get to a point where your main function is bloated, and that's really, really bad. Really bad. Okay, so main name equals main, and what am I doing? Oh yeah. So let's do job description equals model. Let's pass it. For now, let's just say this is a software engineer role. This is going to be like a really long. This is another job role. All right. And then this is a software engineer. This is a software developer position and not a role. This is like painful. Okay, so let's just do that. We're not training it yet. So let's train. Oh, right, I renamed it. So now it's looking at using that 1.3. Oh, right. I didn't do it. So we know what we're going to do. We're going to create a virtual environment. I always, if you're an elite level 10x Haxor, you create virtual environments in Python. Because you isolate your code, you separate your concerns. If anyone wants to become a better coder, the first thing you should do is read the pragmatic programmer. At least like a lot of the disciplines. I actually can have a whole stream where I go over it. That's actually something I should do. It's very, very good. Very good. And I know it's good because all of the smartest people at the most productive companies I worked at, they all understood that this is an important book. And one of them, a large part of the book is separation of concerns. It goes from, it's fractal. It goes from the function level. It goes from the creating folders. You know what I mean? Like it's something really important, because to be productive as a software engineer, you have to not. Oh, I did sort. Well, you have to not misspell a ton of shit first off, but to be productive, you have to not be thinking about a lot of things at the same time. You have to curate your environment in order to think about just one thing at one time, as many times as possible, and sequentially. It's like you don't want to be like I don't want to, like, for instance here, like I probably should have two separate directories, like one for this Python one and one for the crawler. I know that's like super basic, and that's not even that complicated concept, but things like that start adding up, especially once your classes follow that doctrine and your functions. And it's like functional programming is so important, or it's becoming so popular nowadays. All right, so job description model. Let me just double check something here. Let's go back. Just want to see if we're doing good. Okay, yeah. All right, so now I'm gonna go back to this, and I'm gonna make sure that vocab size, job description. Right. So let's rerun this. Oh right, I actually didn't even like install anything. And I changed the environment, so in my global environment I had NumPy, and now I don't. And I think I just need to install Jensen. I just forgot how to install. And it's pip3 install. Okay, so once this is alright, so this is installed. Just installing more stuff. Installing more stuff. Still installing. Oh, it was good. So let's go and CC drawer thing. Is this still installing? It's still installing. Wow, that's crazy. Yeah. So why is this still installing? Weird. Okay, now it's done. It's ls. Let's go. Python. Javascript model. I think we have everything. Let's go. Let's see if it logs, but if it logs vocab size, then we have successfully did enough to train something. And we have to also make sure, so here's another thing I totally forgot. We're going to have to make sure that the vocab size, or the vocab that we use, the new training data has to have that in the vocab. So, wait, why is this taking so long? Oh, you know what? It's because it's downloading this thing for the first time. We don't have to even use NLTK. We're not doing that right now. It's just a way to tokenize text. Alright, let's Python job description modify. Okay. It's interesting. This is like, what is getting imported here? It's taking so long. We also don't need that. We don't need that. We may need it in a bit. But for now, we're being super basic. Oh. That's silly. Let's try this again. Right now we're just building the vocab. Okay. Yep. Vocab size is 9? Yeah, I guess so. Okay. So this is one thing. We have to make sure that the vocab size. So that's another problem with this. The vocab, what we put in, has to be the same as the vocab that we put in. So the reason why that's a problem is because some of these new jobs are going to have words that we don't know. So the way to get around that is we can tag those words we don't know with some vocab thing that we do know. And that's really just, that's the way we can get around that. It's not great, but we're being very limited right now. Alright, so let's do the train method. And let's get total examples. So self-model train. Oh yeah, we should do self-training data. We do self-training data. Corpus count. Epochs. We can do. We just get the epochs. We don't need to do that. We don't need a callback. Callback is just to show some information. We don't need to do that right now. Now let's go here. Let's do job description.train. And let's see. Successfully trained. We're going to go back to this after we're going to go make the crawler after we do this, and we're going to go back to this. Oh. Self.training. Okay. So that took like 0 seconds. So we're gonna just to make sure this works. I'm just gonna show you how this works. Let's where am I going? Let's go to let's do an inference, which so when we infer the vector, what we're doing is we're making a prediction. So let's go, let's say predict, and let's call this like job description, and let's return this vector. And I'll show you an example of what I mean. Job description, predict. We're going to have to save this eventually and pass it to other files and all that. But for now, let's just say this is a role. Obviously, this is going to be overkill because we have like 64 embeddings. Oh, must be a list of strings, not a single string. Oh, wait, what? Why would it have to be a list of strings? Oh, right. Oh, okay, yeah. We have to split it into a bunch of tokens, essentially. I think. Let me actually just see where this gets. Oh yeah, I don't know how file this gets used. Pretty sure this just needs to be a list of strings. And I didn't even log it. Why didn't I log it? Okay, let's print the prediction. It should be like 5 seconds. Okay, that's obviously huge. And like, that's not, you know. Actually, just to show you what's going on here, let's actually make this vector size like 2. So what we're doing is like we're now creating we're setting a vector size, no matter, you know, the document input. We're setting a vector size, and these vectors are now, and remember, this is a role. I'm gonna actually put this in a variable. Print. Here, let's just do input. And let's print the input. Let's use the input, and let's get the prediction. So I'm gonna have multiple predictions. I'm gonna have this is a role. Then I'm gonna have software engineer, and you can sort of just see what's going on here at a very basic, very basic level. I can have this is a job. Like, we have very little text here, right? But you'll see sort of what's going on. 3 cases. Notice how, and it's very, very, very slight, but notice how off this number is from these two. Like, these two are far closer together. And this one's actually close to this one, but these two numbers are far closer than this one. And, well, not like crazy closer, but it's closer enough to like make a difference. And but yeah, so actually maybe I should add some more text here. So like, this is a job and for a software engineer. This is not a role at all, or something like that. And then let's make the window like 3, something like that. Oh yeah, let's do minimum count 1. For now, we're gonna change this all back. All right, now let's go back to this. Okay, so this is a role. This is a, okay, cool. So you can kind of see how this one is like so far off these two numbers, which are actually pretty close together. And when we do the cosine similarity, that's gonna start like mattering a lot, because it's the totality of all these vectors. Okay, so cool. So that's a prediction. Let's just comment that out. Get rid of this. We don't even need to. We can comment out for now. So let's hold this. So we're gonna have to do some more stuff. We're gonna have to do quite a few things. We're gonna have to figure out like how to crawl and get this data. We're gonna figure out a ton of stuff. So let's hold this for now. And I'm gonna break the rule I just said, and I'm gonna actually like write some JavaScript in this directory, because we're just hacking. We're not like being too serious. So, and also I can do anything in it, like Y, I'm pretty sure. Let me just double check I can do that. npm init dashboard. Yeah. License doesn't matter. So let's go. Let's create a job crawler script. So really, this is going to be a super generic script, like super generic, where we enter like 5 job searches for 5 different platforms and do job searches for software engineer. I said like. We enter 5 different platforms, do searches for job engineer, and then we keep scraping until we get a lot of data. Remember, I have to remember later on we're gonna have to do something to mask all of our tokens that we don't like have in a vocabulary, which kind of sucks. But anyway, so we're gonna get the whole job description in a string. Let's just do 5 platforms for now. Let's do 3 actually. So like platforms, I mean LinkedIn. I sure as LinkedIn's paywalled. Or not paywalled, but you have to log in. So I don't want to show you guys my password. So, Indeed, another free one. Alright. So let me create my run function. And we're gonna get Puppeteer. I'm actually gonna just like take all the stuff from the last video. Is this the last video? Oh well, this has everything we need. Alright, Puppeteer equals require Puppeteer. Set a browser. Hold on a sec. Let me go and close my stream. Let's see. Okay. So let's go to Puppeteer and so we don't need to do this. So all Puppeteer is a script, which I used before, which is used well, we can use this to scrape. So we can, it sets up browser routines, in headless browsers, so we can run routines in the browser to automate different things. So it's browser automation. And we're going to do this to crawl. So let's start with like, I think Indeed, we can just like use that out of the box. We may just have to use one. So let's search, ignore that. So let's search software engineer. Okay. Probably don't need my location. And then, okay, how's this gonna work? And then we're gonna have to do pagination. We're gonna have to do this, click on these different pages. We do pagination, we do, so this is how I do this. So it looks like they're gonna make pagination hard for us. Oh no, this is the pagination. Let me just make sure. I actually don't want to do location. Let's see, start at 20. Is that gonna break? Oh wait, whoops. So it looks like start at 20. Yeah, that's it. So it looks like start. This is how we do the pagination. Is we click start, or we move this start by like 10 each time. Is it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, I don't know. But let's just. It said start 10 when we went to the next page, so I don't know. Let's just keep adding this to 10 each time. Even though they'll look like more than 10, but alright, and we're gonna have to get the link for each of these pages. Why does this link say a page ad? And let's say I want to get the best software engineer job, and if I want to get the best software engineer job, I go to Indeed. Just kidding. Indeed's actually not good at all for finding jobs. Alright, so why says page ad as the link? I feel like that's wrong. Alright, well whatever, it took us there. So, okay. So these are the links. We're going to have to get the links for each of these pages. Alright. Let's take this URL. We're probably going to get rate limited, which is life. So let's scrape these jobs. Let's do start. We're probably going to start at 0. Start. Say skip. And this is going to be, so we're going to have a loop. So in the loop, let's do a value called new jobs. And let's do that. Yeah, let's do that. So, and I know this is currently a while true, but we want to set new jobs in here equals something. So every time, so we're going to have a while loop where we're going to loop through this page, and we're going to say every time we loop through this page, we're going to go and oh, it starts at 0. We're going to add this skip cursor, which is going to skip, as we just saw, it skips in the Indeed URL. We're going to add 10 to it. We're going to have to get the URLs we want. After we get the URLs we want, we're going to check the new URLs. And check if new URLs is greater than 0. I know I'm writing this backwards, but it's good to learn how to code backwards and forwards sometimes. New jobs equals, oh wait, let's just say if there's no URLs, well I don't know why there's no, I don't know yet. We're going to instantiate it in a way where it can be null. I doubt it, but we're going to check if this is empty, and if it is empty, then it's going to be false. So that can also be a try catch. We should probably put all this in a try catch. If this is in a try catch, we're going to want to have a function because, if I remember correctly, V8 doesn't optimize code in the try block. So when using JavaScript, don't code a ton in the try block because it's going to make your code slower if you have a ton of stuff in there. Also, it's kind of obvious to not do that. All right, so function jobs or get job URL list. Let's do async. Let's do await. And this is why I like coding in a way where I'm kind of scaffolding, where I do all this stuff around what I need to do. And so after we get this, the job list, so this is like, so let's have a variable for full jobs to scrape. Just jobs to scrape, and then we're going to loop through. So job URL of scrape the job info. So for now, and by the way, just to reiterate, we're currently scraping Indeed for jobs under software engineer. Okay, so get job, and also I want to take a user agent I had from the last video that was good to use. Yeah, I think it was here. Was it here? Yeah, it was right here. I just got my user agent, and then I just used it. You want to do this typically. You want to like say user agent, and whenever you're using things like Puppeteer or like Beautiful Suit, or not Beautiful Selenium, you want to say your user agent because your user agent is gonna. I think the default is like a weird thing, but you want it to look as real as possible. Really, the IP is the thing that they're gonna block you on, though. So botnets. That's the way to get around that. Alright, so this is going to be new jobs. It's going to be false if there's ever an error. Alright, so let's set this new URLs thing. Let's just do that. I think we need to actually do anything in the catch block or log the error. But anyway, so because in the end of this, we should let's just do set this equal to. I know. Yeah, let's just do that. I just like the name of the job list. All right, so let's go and get the job URL list and first thing we want to do is we're going to get all these links, and we're going to go into the inspector because we're lead hacksaws. We're going to go and get all these job titles. So there's 15 here. Let's make sure. I think that's right. This one looks different, but I think it's fine. Oh, because it's a new job. Okay. Yeah, I think let's go to the bottom and see. Yeah, these are all the links. And I think it's the first link in there. So yeah, that's it. So that's how we do it. That's all we need to do. And I like using page evaluate. Dot evaluate. What am I doing? Oh, I have to pass page to this. Page is in Puppeteer is how you actually use all the browser stuff that you're gonna have to use in the page. You're gonna use the page class here. So actually, this whole function is just gonna be the page evaluate, and we go do this array.from, because when you're using query selector all, you're gonna have to create an array from and a primitive array from the class list that they're giving you. All right, so then I'm gonna map each element. Same stuff, the same stuff. Map and see how efficient it is. Like whenever if you're ever worried about scraping, just don't. All you need to do is use Puppeteer. It's great. It's super easy. And I've Chrome installed. All right, so href, yeah, that's what we do. Okay. So I get the new URLs. And I check. So I'm essentially ending the loop here. And so I'm assuming that when this start thing is over, like when it's like the end, this is going to be empty. So this is a risky thing because we're having a while loop that I'm not fully sure if this state's ever going to end. So we can also just say once it gets to 1,000 jobs, just end it. We're probably going to want to do a timeout because we're probably going to get rate limited. I'm just going to, beforehand, I'm just going to do a 1 second timeout. And I'm going to take my timeout script that I always use. And I do a ton, don't ask why this is declared and this isn't, but I do a ton of web scraping now because I'm doing a lot of machine learning stuff and I need to get data. So, and I always have, but like recently I'm doing a ton, so I just got it down pat. I'm telling you, it's so much easier doing this than using Python Selenium and I mean, you should always be doing browser automation in my opinion. Like, it's very few cases where you're not going to want to. Very few. Few websites that matter actually render their content like when the page renders, like server-side rendering of the template. All right, so oh yeah, we want to make this equal to this concat new URLs. Wait, why am I saying new jobs? Oh yeah, new jobs. Let's just do has new jobs. That's confusing. Just make it very clear. This is a Boolean. Okay. Oh, if this is, you know what? I don't even need to do this check. No, I do need to do the check. I was gonna say I could just set that to false in here, but that doesn't really matter that much. I also kind of like separating this out. Alright, so I think this is good for now. So this is the first part. We're getting the URLs. Eventually, after we get the URLs, we're going to scrape the data. This is like gonna break, obviously. So everything breaks. Unless we did it first try. Nope, we didn't. Okay. Because we have a stupid typo. Stupid typos. Stupid typos. Module not found because we didn't npm install. Okay. Cool. So it's no job crawler. I really want this to work. I really want to get to a point where this is actually like working well. Because that's actually going to be pretty fucking cool. Because I could run this like, not that I'm looking for a job, but I could run this like, because I'm at 10x. I'm 20x, so I don't look for jobs. But I want to get to a point where like you could just run this once a day and the whole thing just gets all the jobs once a day, and then you could just always use the script. You could enter in all the job sites you want, and it's just super generic. And this is hanging for some reason. Why is this hanging? Is this doing the thing where it's just like super slow? Because that was happened to me before, which is odd. What is this? Oh, this is the banker bot. Sorry. Consider opting for passing. Let's see. Header, headless new. Let me see if this helps. I have no idea. I thought it was default headless. Wait, what? I'm like getting a ton of like Google Chrome things. Well, I'm not getting the message anymore, which is cool. But so I'm guessing I'm just gonna, I don't know why it's so slow. I'm guessing it's because, let's just see, going to new page, went to new page. Let's just see if that's what's wrong here. Oh, I'm like, I think I'm like acting like this is Python. It's not going context switching. It's never easy. It's never. Yeah. It's the going to new. Oh wait, it already went to new. Oh, it's doing it. I'm just not logging anything. I'm like such a fool. All right. I just did print again. All right. Jobs. It was doing it for like a while. Wow, that's so silly that I didn't. I did that same thing before where I didn't log things and I was like, oh no, it's not working. All right, cool. So we're actually getting links. That doesn't look like a job link. Hold on. Just make sure we're getting the right things. Okay, it is. Cool. All right. So how do we get this job description? So let's go. So on this, we'll just do it. We don't have to be that generic. So we could try using readability to make it generic. For now, let's not do that because I don't want to. I just want to kind of show the whole thing for now. Let's not do that now. For now, let's just. No, let's do it generic. Fuck. Let's do it generic. I'm going to get readability from MankerBot. Where's readability? How did I use it again? Always steal your own code over and over and over again. And then it uses JS DOM. If you don't know what JS DOM is, it is really cool. It's something that allows you to use DOMs in Node, which you're gonna have to do a lot if you're scraping a lot of stuff. I just want to see what this package is called. Okay, cool. And let me npm install. I'm actually not going to get all the pages because that's kind of insane. So let me say page limit equals, let's just get 250 for now. Let's just say if page jobs to scrape length greater than page limit, and just break. So that's just a way we can just break out this. We don't just try breaking. Let's just break. We don't have to do this whole if statement. It's kind of silly. Well, actually, we still need the if statement because this is like the natural end of the pagination. If you don't know, pagination is when you have that little list at the bottom. It's like page 1, page 2, page 3. Okay, so I think this is pretty good. So we go to jobs to scrape. So we're gonna actually see if readability works. I don't know if it does. So we're gonna look at our banker bot, which is not done yet actually. We're gonna see how, like super ADD with these projects, but we're gonna see how this banker bot works. This is how I do it. And I just parse it, and then I get the .text content. Okay. So this is how we're gonna get the actual content, which we could like have our own function. Because I was just talking about not making the main function bloated. We're really already doing it. So let's not do that. So let's get job description text page return readability text content. I mean, for now we're gonna have to log it, but I just think that's what we're gonna have to do. Readability, if you don't know, is a really cool tool for. It's a really cool tool for that Mozilla wrote for essentially it abstractly scrapes article text off of a web page, like any text that seems readable. It's probably going to see job descriptions as articles, like a news article, blog article. So I'm guessing that the job description text, because it's like it'll see dense passages, dense paragraphs, and parse that out. And I think most job descriptions work like that. So okay, so let's go and let's do this page.goto job URL, and then wait. Oh yeah, this is we're definitely gonna rate limited, but it's fine. And let's say job description equals page. Wait, not. Why is it a wait? It's kind of stupid. All right, and this is just gonna be a big corpus of text, so let's actually just do corpus equals this. Oh, we want to save metadata. We want to save, yeah, let's actually worry about this later because we want to kind of make a faux JSON database. For now, let's just log. Let's just test it. Let's actually, to test it, let's not even do. Let's just do like 20. What? Oh, I couldn't install JS DOM. Silly mistake. This is a silly mistake. Alright. This is how I spend my Saturdays. This is how I spend my Saturday nights. If you spend your Saturday nights having fun, then you're not a 10x. This is fun. All right. Wait, why did it take a long time? May have been the timeout. Okay. Article. Oh yeah, I just copy and pasted. Wait, what? Sorry, that's like separate. But I just copy and pasted this without even like looking at it. Let's do. I'm gonna have to pass the URL to this. Yeah, I just like copy the whole thing without thinking. All right, so let's see if this works. Starting with 20, eventually you want to scale it up. But you don't do things that scale. Someone was telling me that the other day. It's a Paul Graham thought. Just do things that work. Okay. Seriously? I seriously did a print again? Wow. That's crazy. That's crazy. Let's see, I really hope that readability works so we can make this generic. If not, like, we can make our own readability, really just finding what has the most, like, p tags in a div. We could do something like that. What? Context was destroyed. What? Sounds like something wasn't awaited. Hold on. Yeah. Kind of, when they say that, that means that we tried doing stuff on the page without the navigation being complete for us to do stuff on the page. That's all that means. So far, Indeed doesn't care, but also we're not making a ton of requests yet. So. Okay, yep, nice. The text content worked. Beautiful, beautiful, beautiful. Okay, cool. Let's see if the title worked. So this actually got us, the title did not work. That's fine. We can actually use the page title, which should be page.title. Just double check. Wait, page title? Is that what it is? Alright, either way, okay, we get the job description, which is the text content, which is working, which is awesome. So let's now use this and make an object with the job text, or job description. Job title, which will be this, I think. And then we're gonna do other stuff. That's it. That's that for now. Whenever I'm using the same prefix over and over again, that tells me something. That's not needed, and this is a class. This is a defined model. Job URL. Doc. this fs dot write file sync, and I'm going to import fs to the file system so we can read and write files. You see I have a pattern of behavior here. I tend to use a lot of the same things. Okay, so let's say job corpus dot JSON, JSON dot stringify corpus. I do a lot of the same things but in slightly different ways, which I like because I think that's the best for learning. Okay, so go to, nice. I think this is actually fine. Oh yeah, I don't know if that's actually how you get the title. This is very sensitive data, so before I actually, oh wait, let me keep this open. Let's see how to get the page title in Puppeteer. Yeah, it's page.title, but is it a promise though? Yeah, it is. Okay. I was right. Nice. So let's see if we're good. So I'm actually double check. Alright, looks good. And I think that the page title, has the job title in it. So we just want something that in the UI or the command line UI for this, we can actually like look at it and it makes sense. So far, we're like actually running this. So we're actually crawling Indeed for jobs, software engineer roles, just 20 for now. And we're gonna, once we do this, we're gonna keep this data set. We're gonna move over to, oh, the excerpt actually is the job title. So I could just use that. Oh, not there. That one's fucked up. This one got the, seems like most of these are working, but yeah, I think most of them are working. Gotta get rid of those new lines. The tokenizing should help with that. Is it done yet? Oh, I'm so impatient. I'm so impatient. Is it done yet? All right, so let's see if this is working. This is cool. So we're scraping Indeed so we can actually start. Yep, and we just saved the job corpus. Let's see if this looks good. Description. We search for title just so I can skip around. Title works, nice. I mean, this one has, Indeed.com, whatever. And what was the other thing? URL. Yeah, I'm sure that's fine. URL. Yeah, URL is fine. Okay, cool. So we have our data set. Now let's use our data set. Let's go back to our script here, and we're going to want to load our data set. You're going to hate me for this, but I'm gonna look up. I always have to look up how to import a JSON file, and I know it's like so simple, but I just got in such a habit of like searching this and copying and pasting it. It's embarrassing. It's embarrassing. I don't need to get all that. Oh, it's literally that. It's literally just this. It's the simplest thing. Okay. It's like just, it's not like anything. It's just like one line of code. Okay, so it's 2 lines of code. Don't need to have the import in there. So it's just JSON load. I just always forget if it's loads or dumps, or, All right, so this is an array of text. So actually what we want to do is we want to train this And then we want to generate embeddings for data set. So we'll do this later. But we're going to have to essentially make predictions on each of these job descriptions in the data set. So now the job list is now going to be the data we just created. This is our data set, our job data set. Let's go pass in the data set here. Let's just call this data set. And now we're actually not gonna do this. This is gonna be job, and what do we call it? We said, wait, why is that not highlighted? Oh, right, my bad. We're doing that here. We called it description. We're just gonna do that. What does tag document actually do? What does this actually do? Paragraph embeddings. List of tag documents. It's actually, now we're actually learning something. I don't know what this is. I used it. So input should be list of tag, good practice. Oh. So it has to be a list of tokens. That's probably why our vectors were messed up earlier. Yeah. I need to, let's use the NLT tokenizer. Okay. Where is that? It's in here. NL, I do it right here. Yeah. NLT tokenizer. Oh wait, no, there's like a pre-processed thing that does it for you, I think. Yeah, it's like this simple pre-process in Gemsyn. We want to tokenize everything beforehand. Yeah, we want to do this. Yeah, let's do this. And then we just pass in the doc. Which, what is the doc? Like, what do you pass? Is the doc a string or is it a tag document? Okay, you just pass it string. Cool. Yeah, so we want to go and we want to use, let's go back to this. We want to, so let's actually just have like a process training data. And we actually just, because we'll already have this set, so we don't have to, the self will already have all the information we need. Let's do self data equals self dot process training data, and so this is getting us the tag documents, but we actually want to do this. I don't like this one-liner doing all that, but I didn't really need to break this out. Okay, I don't know if this is gonna work, but all right. So let's assume that preprocessed it properly. We build the vocab and everything. Let's actually not train it. I want to see if this actually works. So let's go back to Python. Oh, if you don't know, I just searched with Control R, and then you can search your terminal easily. I do that all the time. So let's say we have some spacing issues, we have some indentation issues. Actually, wait, I wasn't paying attention. No, we don't have indentation issues. We have a semicolon, or it should be a colon. Okay. Now we have an indentation issue on line 33. Because this wasn't written yet. Okay, let's go back. Let's run this thing. Pre-press. It's not defined. Why is it not defined? It's because I didn't import it like a fool. Alright, and I did also forgot to re-import this like a fool. One thing I like to do with my imports, I like to have standard libraries at the top. And then I like to kind of go as specific. Oh, cool. That like did it. Nice. Vocab size 2600. But yeah, I like to go as custom. The more custom as I do my imports. Maybe that made sense to someone. I said that super weird way. Alright, so cool. That'd be nice. Let's train it. Let's bring these back to what we had. Minimum count 5. So if there's a doc with less than 5, we're just going to ignore it. Less than 5 words. Let's make this 32. Let's make this a window size of 20. I think that's probably fine. Let's do 2 epochs. I don't think people typically do Word2Vec with a lot of epochs. I actually don't know entirely. Alright, so do I actually say training? I want to do that. Training model. Oh, actually, I want to use this callback thing that I had because it's actually this is good. It doesn't show the loss for Doc2Vec for some reason, or maybe it does now, but it used to not. Let me re-add it just to see. I don't know why it didn't though. Yeah, I even commented out compute loss didn't work. I have to re-add compute loss. So the reason why I'm doing this is because I want to see each epoch and how long it takes. Well, I'm not really gonna see how long it takes, but because that doesn't matter. I just want to see the epochs as they finish. Where am I doing compute loss? Right, doing that right there, and then you pass in callback. So what the callback does is, in Word2Vec, as you're training your model, the callback is essentially giving you asynchronous, like event-based feedback. Okay, so. Oh, it's going to break because I didn't import the callback any to vec. That's cute. They have like other different types of 2vec things. Why was that so fast? Why is the vocab way smaller? What the fuck? Yeah, the loss is still 0. Okay. Whatever. Who cares? But okay, why did the vocab just decrease? Is it me or was, yeah, the vocab size was 26. What? That's confusing. I actually don't know how that could happen. Let me think. Why would, what changed? This changed. The min count. Some of these, this did it. So why? Oh, is it min docs? Is that why? Let me just change that back to 1. I don't know. Why would that? Do a lot of these... Whoa, why did that change it that much? Huh. Okay. Alright. I don't know. So one thing we could do is we can have like a self start time 0 epoch. So I want to get the time. So let's do start time equals time dot time. Let's import time, standard library, goes at the top, and so we can say minus this equals total epoch time, and then print time spent, or it's time of execution. This is a seconds, I believe. Pretty sure. I guess that's seconds. Yeah. Anyway, okay, so cool. So we're training the thing now. So we have to. So now. Oh, well, what we can do is we can generate embeddings for the data set. What I mean by that is we're going to want to create a file. So now we trained, we gave it all the text to train the representations of each word. So we can vectorize. And I think there's like some embeddings table or something. But so we can vectorize the words now. So now what we need to do is go back and infer all these documents so we can create embeddings for each of the documents. And so there's another thing where we have to do that masking thing that I said. I'm going to talk to a buddy about that and see if that's actually what I want to do. Job finder. So we're finding our jobs. So let's go and generate embeddings for the data set. And right. So we want to self dot job data set. So for job in the job data set, we will job description self dot predict job description. And oh, we don't want to do this anymore. We want to pre-process this. Simple pre-process. Is that going to work? I think that's going to work. Okay. We want to predict. We get our embedding, our representation of vectorized representation of the data, and we want to store this. So let's actually do this. Let's do, this is an array, so actually enumerate this and get the index. So we can, because I think it's not, isn't pass by value, so I think we have to do this embedding equals embedding, and then let's have a save new data set. That's kind of weird, but let's just say save data set. And then we'll do job corpus or job data set. This is with our embeddings. I think it's right plus. Let's f as f. Let's do f dot right. I'm like, am I doing this right? But let's do f dot right self dot job data set. Let's do JSON dot dumps. I feel like I like never write that, just like ever. All right, so if we train it, then let's generate. Let's do generating embeddings for data set. And saving data set. Okay, so let's go. Let's generate these embeddings. Job description instance generate embeddings and job description dot save data set, and let's see if this actually. Why didn't it just work? Why didn't it just work? What? Self dot predict. Oh, I did predict. Typos. That's not 10x. Saved it. Actually, do it. Let's see. Embedding. Nice. It did it. Cool. So we have the data set. So now we can do some comparisons. So let's do, so the predict, before we do a predict, let's do a, because I'm pretty sure if you pass in something that's not in the vocab, let me just double check. So pass in words not in vocab, word to vec. I mean, I like know this is true, but like, yeah, I want to see how people treat words that aren't in the vocabulary. Yeah, we don't need to lematize. I mean, like words that literally just don't exist. Yeah, 0 vectors assigned to them. Wait, but that's not. I don't think Gensim does it. Let's see, Gensim 0 vector word non-vocab. That'd be great, but I don't think they do that though. Because yeah, they have this keyed vector thing, and it's gonna have a key error if it doesn't exist. Okay. Well, let's just try it out. Let's just do predict for, let's do a prediction. Oh, we have this data set, so actually, we can save the model so we don't have to train it every time. But it's fine. Let's just do that later. What's like a word that doesn't exist? Word that doesn't exist. Oh, that actually showed up. Pew. I might be overthinking this. Yeah, I'm overthinking it. Yeah. No, it deals with it. It zeroes it out. I mean, it didn't zero it out here, but I think it just did some. It dealt with it. Okay. Cool. All right. So, yeah, we don't have to do that. Nice. Now, let's make the routine, the actual script that we want to do. So, should we write? Should this be a Python? Oh, wait. No, this should be a Python script, like command line tool. We don't want to do because we already do the stuff in JavaScript to preload everything. So let's make a command line tool. Oh yeah, let's save this model first, which I already have. Because we want to load up the pre-trained model. It's pretty easy. We just do save model. Then we do model save. We'll say job description model. It's not HTML. It's a separate code base I'm using. So we say model saved. Let's do train. Let's do save model. We're already training the job. We're already generating the embeddings. All right, so let's do this. This is really all we need for this script right here. So we created this word to vec thing. So what we need to do now is, and we have this job description model file, we need to create a script. Let's make a Python script that takes in super Django. We're not even going to use an argument parser for now. We're just going to pass in a URL and just get the argv. Let's call this lead job finder.py. And we're not even going to use a class. I'm going to realize. Let's use a class. Actually, no, I don't care. So let's just do import, and then let's make a load model. I think it's just the same thing. Oh no, it's like a little different. Self model equals doc.debec load, and it'll be the same thing. Okay, import job what do I call it? Okay. So let's go back to from job. Oh. Hold on a sec. Let's rename this. Forgot how to deal with dashes. I know. But yeah, let's import job description model. Let's import the class. Remember, that name if statement is not going to run. The if name because main is importing it. It's not a main module. So let's create a job description model here. So actually we don't need, when we run inference, we don't need to pass in a data set. So let's default this data set to null. Let's say if job data set, if the length of job data set is equal to 0, well, yeah, let's just return. And then model won't exist. So, do with that what you will. The reason why, then there won't be training data, right? So the only thing we can actually do when we initialize like this is predict, is we'll load, save, predict. All this other stuff is if we actually pass in a data set. So we're just making it so we don't need to pass in anything here. So when we made it, I just realized I made it a argument instead. So now this needs to be like that. Okay. So let's go to job description, load model, job description dot predict Oh yeah, so we need to parse the URL in here. So oh yeah, that's why I wanted to do it in JavaScript, because I wanted to like actually parse the job description and use that as the job description parser, and then we could just run. Yeah, yeah, yeah. Let's do that. We want to make so we need to go back and forth. Hmm. Actually, for this, just for sake of time, let's just use Beautiful Soup. Let me just see if Beautiful Soup can work for this page. I think it can. Yeah. Yeah, I think we're good. I don't like that though. So I think, how do we do this without? So we use the node script, and the node script will, what'll it pass to? It needs to pass the whole description to the Python file. So it needs to have like a temporary file for the Python file to read. It's actually not bad. That's not bad. Yeah, that's not bad at all. So let's do that. Let's go, and because the problem here is doing this whole readability thing in Python, it's not like that much harder, really. We could also use Selenium, but we already have a whole setup in Puppeteer. So let's just write the script. I'm trying to think if there's well, you know what we can do? We could just fire off that script in Python. Let's fire off a node. Let's make a node script just for that, because I actually do want to keep the script in Python rather than do all the. I want to keep the script in Python for sure. Okay, so let's do single job parser. I don't need to make it run. I know. It's pathological. All right, let's go run. All right, we're just gonna copy like half all this shit really. All right, and we're just gonna. I mean, it's the same stuff, right? So, I mean, we don't. For sake of time, we're copying this. We don't need to, like, in the real world, we don't want to copy all this. I just want to make that very clear. Like, I don't want people thinking that you need to just copy a ton of shit all the time. We want to have the utils. We use this, but we're not doing utils. Come on. All right, so we have an argument to this file, which I forgot. I know it's like .args or whatever, but yeah, process.args, argv. Okay, oh, it starts at node, so we want to get argv2. But process.argv2, because we're just going to run it as a node script for now. So this is actually going to give us the URL that we passed to the script, and then we're going to want to do this. And this is going to give us, and then we're going to have to copy all the shit we did down here to get the corpus. So actually, we don't even need to do this. We don't need to do that. We just need a job description. And then we want to save this to some temporary file. Where am I at? Right, single job parser. So let's save this. So this is the description. Let's do, why am I making space between everything? So let's save this to temp, like, let's just say like leet description temp dot text. And let's just say the description. And I think we have to do UTF-8. And that's it. So when this runs, oh wait. No, this makes sense. So we're gonna run this from the Python and we're gonna write this file. So this is the initializing file. We have to run process Python subprocess. Haven't done this in a bit. I just want to make sure that, I mean, it's super simple. I just want to make sure the feedback is all good. And we're not, oh, you know what? I want to make sure this is actually exiting the process properly. This is an async function. Yeah, oh wait, wrong file. I want to make sure this is exiting the process properly. So, because I think it's gonna hang. We didn't do that. So okay. So we just need to. So we're spawning a subprocess. So we're essentially just spawning like a bash script. That's gonna. Where's the code example? I was just looking at. Okay. So it's just subprocess.run. So when this runs, we're gonna have to get the argv, which is. I gotta look this up too. Process Python sysargv. Right. So we gotta import this, import sys.argv 2, the job URL, and we want to say, we're going to do all this stuff later, but up here we want to say subprocess.run, and I think it was like that. We want to say node, we want to say single job parser.js. We want to use URL. We want to say job URL. And I think we want to do it and use double quotes. All right, so let's see if that does anything. Let's just comment that out for now. It's Python leap JF list is out of range. Oh yeah, I didn't. Hold on, let me get a job. I accidentally opened this up. I'll just use this one we already have. Hopefully, when we do the similarity, it actually gets this one. See if this actually like does it. What the fuck? What the fuck? Hold on a second. What? Why would that be out of range? Oh, because it doesn't include a Python here. Oh, okay. Okay. So now it's running our JavaScript, right? Yeah, nice, nice. Okay. So navigate to invalid URL. So the URL is invalid. I think I know why. Because this file, the argv is messed up. So let's actually console log. Oof, fever dream. The argv that we have. And I think it's because it's including the quotes, which is dumb. I don't think we need these quotes. Let's try this again. It's actually kind of seamless. Yeah, like you can communicate the files with temporary file. I mean, communicate between processes with temporary files. It's not that big of a deal. Yeah, it is. It is too. Oh, page evaluate is undefined because I'm not passing page to the function, right? Yep, that's why. And URL is process RV2. This is like kind of first try. We're like, it's like semi first try. Okay, that shows I'm not in the right folder. Did that create it? Yeah, and nice, nice. It created the text file. So now we're successfully running our node script to parse the node. So now let's actually create the job description, load the model, run the prediction. So in the way we're going to run the prediction is we're going to fs dot. Wait, actually, I'm like, now I'm using fs in here. I lost the script. All right, so let's just read. I'm gonna look up read text file. I just want to make sure I'm doing it right because I typically use this, this read lines thing. I don't like having defining variables in indentation, but whatever. So job description text equals lines dot. Let's just join them. The tokenize is going to get rid of that. So we're joining all these lines on a new line break. Let's do the predict on this. Let's get our vector. And if once we get this vector, if this actually works, we're golden. The reason why we're golden is because once we get that, we'll be able to, once we get that, we'll be able to do our ranking. Which I actually haven't really thought through. You know, halfway through the video or near the end, I'm like, how do we actually compare these? This is running. Let me actually do that. Actually, it's probably done. No. Okay, but so back rank vectors. How do people do this? I'm just gonna use cosine similarity, but I don't know. I'm like totally wrong about that. Get rank of similarity. Oh, I called it load modal. That's how much I've been coding in React. What the fuck? Alright, let's run that again. Where am I going? What was I just doing? Right. Stack Overflow. Oh. They have a ranking algorithm that just already does the oh. What the fuck? Wait, so does Doctivec have a rank? This is like hilarious. I was like so confused on how that works. So the problem is the same primary needs far more data to working 9 tests. Yeah, okay, sure. But, okay, so this is someone asking how it works. So their implementation is probably fine. Similar coast model.db. Okay. I think we want to do this. Let's do rank Oh, to do the ranking, we actually do need to load up the data set. Yeah, we want to do. Oh, we want to load up the generated embeddings. Actually, dude, hold on a second. Yeah, wait, how does this work? I'm not even know how this works. Hold on. Model.dv, most similar. So is this getting from the training data? From the data it was trained on? Actually, don't know how that works. Let me just look at the docs. Rank. Most similar. Okay, so we have an inferred vector. And then we have the like one of the documents in the corpus. And then oh, it's actually I think it's gonna get the document IDs. Yeah, yeah. But the rank is index with the document ID. Yeah, okay. I think that makes sense. Um, that's weird. It's not a big deal though. I just want to make sure. Just do this first. Rank for just say vector. Okay, let's do this. Let me actually just print this out because we don't really know what this means. And then we can go back to this, and then we can print. So we have the vector, so we know the vector. We can now say job description dot rank vector. And that's just gonna print something out. So we'll see. We'll see. Eventually, we want to scale this up to a ton of different jobs. Now we're just doing 20. Now it's Sunday. All right. Key is not. Oh wait, what? Not passing the data in right. Where is the model? Well, that's what I thought. I thought that was weird. Oh, no, 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 no. This is what they're doing. They're saying give me the most similar with the inferred vector. So I infer a vector from the model. So we get the vector. We did the to list thing, so maybe we don't need to do that. I don't think they do that. Yeah, they don't do that. I think it's just because it's NumPy. But they had like a key error because they thought it was in the vocabulary. Key is not present in vocabulary. So, and I'm guessing this is the length of the vocabulary. So in the length of the vocabulary. And also this is like WV, not DV. Which I'm guessing is document vector. Let me see if this key error shows up somewhere else. Yeah, why don't we just do this? Oh yeah, this is for words. Yeah, yeah. Is there just something like this? Like honestly, this is all I want. DV. I don't know. Oh, hold on a sec. Description. Description. Two. I think the inference happens in the ranking. So let's actually do this. I think we do want to load this up with the data set. So let's go. We want to do this. And then we want to predict vector rank. So let's not do this or this. Let's get the description, and then let's get like the first thing from the data set. I think it's an array. I'm assuming DV means document vector. I'm not like fully sure. Or doc vector. I appreciate Gensim, but some of it seems half-assed. I appreciate it. I also like how we're not trying to get really limited because we're like not even doing that many requests, which is awesome. Okay, job data set is not defined. Wait. Wait, this never happened. Process training data. Wait, what? That never happened. That's crazy. We just had a typo. I thought nothing would have worked if that typo existed. Model is not defined. Right, okay. That's fair. Let's do it again. Nice. So what is this? The key is for the whole like. Well, I know this is not a key, the whole doc. So I'm assuming we need to pass in like we need to tokenize both these things. Well, okay, all right. So we can do that in the model. So we can simple preprocess this, simple preprocess this. And I don't know if this is going to be, I don't know what it's going to be. I'm assuming it's one, it's just like a floating, like a float. String to float. Description. Wait, what? Line 30. Oh, wait. Convert string to float. So it did JSON load. Cannot convert string to float. Description. What? Oh, it's happening inside the function. Okay. No, actually, I don't think it is. Cosine similarities. It is using cosine similarities. And what? Okay. Let's just print out this description. Cannot convert string to float. When I'm like not sure what that is. Okay, what got logged? Yeah, this is a description. Yeah. Okay. Simple pre-process. I'm doing something wrong. So why would is this like description in one of the keys? Because that the odds of that seem really low. Let's do doc to back. This is like such a. I know this is simple. Yeah. Let's go back to this one. This one probably. Yeah, I know. I need more documents, sir. And I forgot how this guy do it. So. Oh, this is actually what I want to do, and I like pretended like this didn't exist. This rank. Hold on. No, the score is what I want. The rank is just the number. Let me just copy and paste this. Rank. Documents, doc ID. Where do I get doc ID? Vectors. DV. Positive. New vector. Yeah, but this is the same thing where the new vector thing doesn't work. Self.model and score. And join documents. Oh, yeah, I don't want to do this. Let's just do what order are these documents set up in? It's right here. And then it's just enumerated from job description. So that means I can use job description, job data set right here in doc ID. There's no words. So I can just get the first 20 characters. I don't know if this is gonna work. We'll see. Let's re-add this. Let's add this. This is gonna go through the whole data set and do. Wait, what? Oh, It's tabs and spaces. This is going to do the same thing. I'm just going to convert it. I don't know if you know about this, but you can convert tabs and spaces like that. These pretty easily. Any Python people hit any walls? Okay. So unknown type list is on line 29. Rank vector, it's on this line. And then in all words, oh, unhashable type, list. Because it thinks this is going to be something hashable, which it is not. So it's not, this isn't the key. But it's assuming that I'm going to pass in a key here. It's weird because in the example, it's actually just a vector. So, and, oh, let me go back. So how does he use this vector? So yeah, he does a vector. Oh, and he splits it before he does the frets. Which I do. There's the two lists. Maybe I don't need that. I split it. What I mean is I tokenize it. I don't know. I just opened up the mail. Maybe it's the two lists, but I don't know why that would. Because the list part is just converting it from NumPy. I'm pretty sure. Maybe I'm wrong. I don't know. Format. This is cool. If this works, this would be cool. Why is that opening? Okay. Oh, nice. Oh, but it did. I don't know if you know what it did here, but it didn't work because it did the it's interesting. So why did this get missed? These numbers look weird because they're separated by spaces. Oh, because they're NumPy. But so this actually, oh, you know what? I think I trained it on characters. Oh, because that's what the simple preprocess does. So that's why I got the NLT tokenizing. Okay. So we have to retrain it. That's okay though. I mean, it actually did rank it though, which is cool. All right, so let's change this tokenizing. I'm sure some random like genius watching is like, oh, he finally figured that. Fucking idiot. Oh, and that's why the comparison of the text was so weird too, because I think it was using that. All right, so let's go into our. This is what I was doing. I was just doing word tokenize. So we really just want to do this every place where we use it, which is only there. Is that one? Yeah, I think that. Oh no, pre-processing the data, obviously. I'm gonna do that. Okay. So it's not a perfect tokenizer, but I think that's good. Let's actually go back to running the model. Oh. Wait. What? Oh, I did the underscores now. Jot. Okay, so let's run this. ND array is not JSON serializable. Oh, that's why I was doing that. Saved. So before it gets saved to the data set, I want to do the to list. This needs to have to lists on the outside of it. Let's do that. Oh, and the tokenizer is more vocab. It's more. It's a higher vocab now. Which does that make sense? Wait a second. If it was characters, wouldn't the vocab size be like huge or really small? I don't think. Yeah, no, I don't think this is. That's what the problem was. Let's see if this makes things better. The vocab size makes sense for like 3,000 or 2,000 for words with like 20 different articles. Still, oh, it's just because of this. The tokenizer was fine. Wow, that's so silly. It was because I copy and pasted stuff and they did a join on all the strings here. Yeah, they joined. It added the space in the format, the string formatting. All right, so it's actually doing it, and it's the same response as before. It's a little different. It wasn't actually doing characters. Okay, so these are, I mean, they're different numbers, but yeah, I mean, we're gonna need a lot more data. But let me see. So the best one was the PayPal one. Is this the PayPal one? What is this? This is. Well, this isn't PayPal. Citizens. Is this ranked in the right way? Let me actually return the URL. I actually don't know why it's only showing 5 or 10 things too. So what does this actually do? Find the top and most similar. Oh wait, top end. Am I passing n? Okay, but oh, top n equals 10. Duh. So that's the default argument. So okay, it's a long story short, it's a comparison thing. Oh, but I'm saying I pass in what the positive and what the negative. I don't want to do that at all. That's not anything I want to do. Let's. So I'm gonna go into. I'm just gonna do most similar. Do they have like a generic most similar thing? Oh yeah, this is not what I want to do. What do they have in the utils? Those they're like there's a rank thing. Yeah, similarities. No. Yeah, it's Doctivec. Similar by vector. Yeah. Wait. Top and most similar words by vector. No, I want to compare two vectors. Compute. Okay. No, it says two sets of words. Yeah, that's what I want. Yes, this is what I want. Okay. And similarity. This is what I want, because really the doc is like a set of words. But actually, hold on. I want to see, is there a better thing I can use here? Otherwise, I'll use that. Right. I think I just need to use in similarity. I feel like it's better to just compare the whole matrices, right? I'm gonna look back and be like, wow, how did I miss that? Looking at this. For now, I'm just gonna do this, and that's fine. So let's just, for now, let's just do and similar for description. Oh wait. And similarity, yeah, it just gives me straight up cosine between the two words, which I think is not what we actually want. So what we want to do is we want to loop through. So for job in self.job dataset. Description, job, description, and then I want to enumerate this. I want to get the index, update it. I don't need to update it. Hold on a second. Let's just make this a sorted function. Like with lambda. Oh, wait, actually, it's very easy to do that. Anything I need to take from you? No. So, I believe we can just do that. I think. Verse true, because wait. I mean, that's not what I wanted to do. I wanted to just, like, I have to map it and then I need to sort it. I don't know why I'm doing all this. My brain's getting too fuzzy. I gotta end this soon. Alright, the reason why I did this is because I didn't just do the original way. Job data set, score. This is like stupid. It's fine. So we can now do the sorted. Actually, there's like a key sorted thing. Yeah. So we can do dataset key equals score, reverse equals true. I think, yeah. Sorted. So this is going to give us the most similar. Or actually, let's do, and let's actually delete the description. No, actually, it's not. Only because I want to make the output a little bit better. Looking a lot of shit up. I just forget if like this is on the iter tools. No, it's not. Okay, so we want to map. This is not optimized really, but it's fine. We want to map the what was it? The iteration. Oh, the iteration was after. The function is the first thing. Accidentally opened Firefox. So we want to say X, and then we want to say X description. No, we don't want to. We want score. Let's just do title. Title, comma, score. I forgot, if you just do that, is the lambda going to return it? Let's see. Lambda function return dict. Oh, I didn't mean iterate, I just meant return. That's not what I want. I'm pretty sure you just do that. Yeah, it's fine. Okay, cool. So this is gonna map it. This is our data set. And then we want to pass a data set to this. And we're going to return this. Let's do top n equals 10. And then let's do top n. This. Let's do the rank. And let's lose. No, I'm kidding. No, this might not work, so. Alright, we don't need to do this anymore. We can now, just do this. And equals 3, just get the top 3. If this works, I'm gonna feel so good. So now we're just trying to figure out how to use this built-in cosine similarity for GenSim on the Doc2Vec model. Long story short, how do we get the most similar job descriptions? Oh, key error score. Line 83. Oh, did I do something before I could do it? Oh, I didn't set the score. Wow, it is late. Okay, let's do this. You know what? This isn't going to work because this needs to be converted to a list. I know that. So let's try that. So I think I think it's an enumeration when you pass, or no, it's an iterator, something like that. String is not callable. What? String object is not callable. Is that because of the score part? One second. I want to use look an example where you use sorted. Key. Oh. It's a lambda function. That makes sense. I don't know why I was assuming I could just pass in a string as like a key. You know what a lambda function is? It's a nameless function. It's like an anonymous function in JavaScript. Oh, I'm not printing out the results. It's a rookie mistake. Results. Print results. Let's just get this done. So I have a script where I'm passing in a job URL and I want to get similar jobs. This is like a software engineer role. Okay, nice. Shalimar, Florida. The scores are 0. So why are the scores not working? You know why? These are supposed to be tokenized. I hope so. Yeah, because these don't exist in the vocabulary, so it's going to be zeroed out. So it's just going to be 0. A vector of 1, which is 0, cosine similarity of the vector of 1, which is 0. But we want to tokenize it the same way we tokenize it in the training process. And it's still messed up. I was like so confident that would work. Just make sure. So it tokenizes the description. Then it tokenizes this description. Maybe that's a score. Reverse true. Pretty sure it's the right thing. Let me just see. Let me just get the length, not the whole thing. Let's see. It should be citizens, by the way. That should be the most similar one. I don't know what the title is though. Oh shit. Yeah, it's like 0 a ton of times. What? So, what? Why would it be 0? N similarity. Does it need to be the same size? 2 sets of words. That's similarity. I think it might need to be the same set of words. Alright, so I just want to do like a basic Maybe I need to do something smart with this. This is stupid. This is stupid. I just need to do two predictions and then compare the two predictions. I'm not going to use the built-in stuff. I'm just going to get a function for cosine similarity. It's just, yeah, NumPy has one, right? Yeah, it's literally just the most basic shit. And I just need to get this normalization. And I think this is fine if I just use the vectors. I think. Like the vectors I get on the inference. Pretty sure it's all I need. Just need to run inference for both these things. So I just need to do predict. So I just need to do self.predict. So A self-predict B equals self.predict cosine score cosine score. Okay. I think that's fine. Because, like, that's the whole point, is that, like, this would have to work. This would have to, like, pretty sure this would have to work. And it did work, I think. Let me see, Iceland, this is the most similar one. Please. Yeah, nice, it worked. Nice, nice, okay. But these are like super similar. So this is the most, so nice, we got it. So we did it, cool. Now I actually want to overload, I don't know why, this is the first thing I thought to do, and I was like, oh, let's use like the built-in Jensen thing. Jensen sucks, apparently. All right, so I appreciate the Jensen. But, all right, so this actually works. And we're able to get, so the first one is, so we're still comparing it with the same one. That's why this one's matching. This software engineering hybrid one is similar. We only have like 20 data points. There's like a senior software engineering. But I'm sure if we load this with like a ton of different stuff, which like I can run that right now. I actually want to run it right now. Let's see. Let's do job crawler. Let's like run this for a bit. Let's run the job crawler for like maybe 500 more. Is that too much? Just do 250. What? Oh. What? Oh, because I'm doing. That's silly. Cool. So far what we did is we create a crawler to crawl Indeed jobs, software engineer roles. It's generic script, so we can actually use pretty sure we can use any job page if we want. We made a really basic, we're not using OpenAI embeddings, super low cost, super basic script to train a word embeddings layer for us, so that we can do predictions on these words to get to vectorize the words, and then we get the top most similar jobs based on any job that you can actually pass to this. So we're just passing a job that we already know. And they're actually checking if our connection's secure. So I'll do this later. They're starting to rate limit us. But anyway, so we got that working, and yeah, the script, so it can actually package the script and use it. If anyone wants to use it, you can let me know. It's pretty basic. But you can also look at the video and see how it's made. All right, but I'm gonna go to sleep. So see ya.